Okay, guys, let's get started. All right. We'll now run through the electrophilic addition. Then I'll show you the carbocation, and from the carbocation, we discuss which is more stable, which is the major species. And then after that, I'll give a twist to the question, right? We'll discuss how that affects the stability of the carbocation. All right. What is also interesting for us to add on, put another layer to it, is that we're going to discuss what happens if the reagent is aqueous bromine, which means there's water inside. I want you first to bear in mind, as we keep explaining, throughout organic chem, in your A level, remember, water is a nucleophile. It's not an electrophile, right? It's a nucleophile. So if you have aqueous bromine, bromine is the electrophile, and bromine, although despite the fact that it's non-polar, when it approaches the C to C double bond, which is electron rich, it will be induced with a dipole. Therefore, because of that, it will be delta plus, delta minus. So in the exam, if you don't label delta plus, delta minus, they will penalize you. And typically, you will forget to label them. Reason is because you will have thought to yourself that, after all, bromine is non-polar. So it shouldn't have the delta plus, delta minus. But you forgot the fact that when you get very near to the C to C double bond, it's induced, all right, with a dipole moment. Okay? So in this case, the electron will go to this fellow will take it this way. So you have two options. So option one, all right, we're going to have a different color for that. The bromine goes here. Let me use a different color. You have your option two, which is this. I think the central idea is that you need to remember we're discussing about alkyl group, right? So quite similar to the questions that we did in alkane, remember? Where we actually have a radical. We tell you that I want to draw back that information because so that you can actually relate to this. And I want to assure you that the concept is always universal anyway. So okay, so this is your primary carbon with a radical. This is secondary, this is your tertiary. All right. So I want to tell you between these three, this is the most stable. Is this way? Huh? Why is this the most stable? Radical means they have an unpaired electron, means they're short of electron. All right. So as we explained, and you're going to keep hearing that, electron releasing alkyl group. Release electron to the carbon with the radical. So imagine I'm a carbon with a radical, I'm short of electrons. Everybody release the electron to me or share the electron cloud with me. I will be stable. All right. I'm no longer so short of electron. You will find that for this case, you actually only have two electron releasing group. For this one, you only have one. So this is the least stable. If you are the least stable, that means the amount, you will only have very few of that that's formed. This one, you will have a lot more. Okay? So that's the understanding. Okay? So in the same vein, I'm applying that on this now. So you can see that now you have two alkyl group, correct? That release electron. In the case of this, can you see that there are actually three alkyl group? So hence, because of that, the red one is actually more stable. And the key phrase to use in the exam to impress the examiner is to say that more, because here, maybe here, more electron releasing alkyl groups to disperse or what? Or reduce the positive charge. So more stable. So if it's more stable, you will end up as the major species. So you must remember, this is actually major, this is minor. Which means, never mind, if I were to draw the major species, it means this is the major species. So if I can pull it down here, okay, this is the BR. It means that there are actually two possibilities now. So after this happened, you actually have your BR minus. Your BR minus could go in, or your water could go in. Okay. So the first thing I'm going to do is that let's see what happened if the BR minus goes in, which is quite straightforward. If the BR minus were to get in, all right, you will find that you end up with actually this. Okay, and then of course you have your H2O on the side. But if let's say end up is the water that gets in, then you need to see that this is actually the case. It will be like that. Okay? Because you'll find that this will bind here to form HBr. So I want you to remember this is actually the structure for it. Okay? This part very important for exam, whereby we give a twist to the question. All right? Let's try and do that. So say for example, the twist to this question now is that I decided to put a Cl here. So if I decided to put a Cl here, in this case, we have to rub away all the alkyl group, the electron releasing part, and we have to reanalyze it. You need to see that when we decide to change a question and decide to put a Cl here, right? The first thing you need to realize is that this Cl is now directly bonded to the C+. Okay? And you need to see that all the electron releasing effect of an alkyl group now becomes secondary, because after all, alkyl group don't have such a difference in terms of their electronegativities. Unlike your Cl, Cl is known to be highly electronegative. So in the presence of this Cl itself, the Cl will do what? So the highly electronegative, highly electronegative Cl, all right, would what? Would enhance or increase the positive charge of the cation. In this case, if you enhance or reinforce, sometimes we use enhance or reinforce instead of increase. Okay, reinforce the positive charge. What does it mean? It means that the charge becomes, the carbocation becomes unstable. So it's less stable. So it's no longer the major species. Okay, you will find that it becomes the minor one. This in fact becomes the major one. Why is this the major? This is the major because the Cl is still quite far away, and therefore, thank God, you still have a couple of electron releasing groups that can still release some electron to this. So this now become the major species. Okay, if this become the major species, like what we did earlier, let me pull the structure here. This is the plus now. So you actually have a Br minus, all right, that can get in, or you actually have your water. Okay. So you'll find that in terms of the, let me not forget the Cl. So in terms of the species, major species that you get, of course, one of it is none other than this, where the Br gets in. So that's a simple one. If the water gets in, then in the same vein, this is what happened. All right. So you will end up with actually this as your major species. Okay.